All right, here is another video on the parallel axis theorem. Make sure you have your CYU out. I'm going to just solve the problems from your handout in my whiteboard on Zoom here, but I'll read the parallel axis theorem from your handout. So the parallel axis theorem says that the moment of inertia of an object around a particular axis is equal to the moment of inertia of that object around a parallel axis that goes through the object's center of mass, plus the moment of inertia of the object treated as a point at its own center of mass, rotated around the new axis. What does that mean? Um, you have a bunch of formulas for moment of inertia. And for the most part, all those formulas on your old handouts are formulas that have an object rotating about an axis through its own center of mass. So for example, for a disk, its moment of inertia about its center of mass axis is 1/2 mr squared. But what if instead of rotating around its center of mass, what if we wanted to rotate it around an axis over here? What could we do? So this is the first problem on your handout. What we're going to do is we're going to take, so for the new axis, we're going to take the center of mass moment of inertia, so the formula. We can call it the center of mass moment. We're going to add it to the moment of inertia if we imagine that this whole object is a point mass at its own center of mass. And we're going to rotate that point mass about the new axis. So instead of having a disk, we're going to just pretend now that we have mass m located here. And as it turns out, that's r away. We went one radius away from the new axis. So the moment of inertia of this point mass that we're imagining would be mr squared, right? It has mass m, and the distance from the point to the new axis is r. So the moment of inertia of this disk about the new axis is 3/2 mr squared. You'll notice that by moving the axis from the center to the edge, we tripled the moment of inertia. So it's 3 times harder to get that thing to start rotating than it was before. And hopefully that makes sense because moment of inertia depends on the distribution of the mass. And in this second version, there's so much mass that's a lot farther away from the axis than the mass in the original disk when you're rotating about the center. All right, you now have a couple practice problems to do. The next one is where should we put the axis on the disk to get a moment of inertia of 3/4 mr squared? Okay, where should that axis go? So it would be half as big as the moment of inertia we just calculated. And then there's another one at the end about a rod. So if you have a 2-meter long rod, you have a formula for the moment of inertia of the rod about its center, and it's 1/12 ml squared, where L is the length of the rod. But what if instead of rotating it around the 1-meter mark, you rotate it around the 0.4-meter mark? There are 2 ways to do this one, and I want you to brainstorm with your table both ways of doing it. Do it both ways, see if you get the same answer, and then you can flip over and check the back and see what those 2 ways were. My hint is that one of them involves the parallel axis theorem and the other one doesn't. All right, good luck.